Just return. Okay, can you write anything?
Yep.
I think it is B, right? B.
Yeah.
A is magnitude. B is omega. Instead of use omega, they use B. Yeah, that's the only difference.
Yeah. The school. Let me see. They haven't. I looked at it today. They use.
Yeah. Oops, sorry. Yes, go on.
Just trying to find. I think they use. I don't think they use the.
This is what they use. This is sine B, right? B bracket x plus c. That's how do they use? Okay. We just stick we're sticking with this one. Yeah, go
on. So in maths B, they use stuff like fx equals like a sine. So they use like nt. So n is basically omega.
Oh no.
Like.
Oh,
and then
wow. Too many notation. You have to stick on with, you have to stick on with, because n is not good, because n is often used to represent the integer, okay? So n is not a good idea.
And in specialist, in Math C, normally it's probably like, it's normally like.
That is the one. So that's Math C.
That's pretty much how they do it in that. Sometimes they have it a little bit different, but normally it's a bit like that. Normally it's like that. Normally we don't put in Math C, it's just x plus c.
No C, right? No C.
Yeah. No B. They don't have a B. They just have a theta plus, or like, maybe
no. I'm talking modeling. We use this as a model.
Oh yeah.
When you do modeling, you must have 4 at file. 1, 2, 3, 4 numbers. I'm talking modeling. When you use the sine as modeling, you have to use this formula. Okay. Well, when you write a sine function, you can just write anything. You can write this way. That's all. Okay.
Yeah.
The important thing is that if you have, this is easy because you know that this is a period. So basically, so x. So not this one. We're just talking about the periodic function. Do you know by definition? So x plus 2 pi, right? Or equal to a sine x. Do you know that one? That is by definition is
yeah. So
how to define this? In this case, this is t. So in this particular case, t equal to 2 pi.
Period is.
If this is just x, there's no number here. There's no number in front, no coefficient in front.
It'll give you the same answer because it's just you just add 2 pi.
Yeah, I'm talking about what is, so what is, do you know what I mean? What is a periodic function?
It has a
function. Oops. Function. Can you answer me? So how to answer this question? So if x is a periodic function, what can we say? How do we write mathematical definition for a periodic function?
Is that the thing on the left? Like if x equals a sine x.
If you given period, if you given t is a period.
T is period, yeah. Then
go on.
fx equals f.
Can you
x
write?
Plus.
Can you write here?
So if t is x plus t.
No, more than that. The complete definition is x. So basically, you can just rewrite it that way. So x plus nt.
Nt, yeah.
Will equal to fx. Okay, what is n? So n is just numbers, integers. Yeah. Because 1, 2. You can go infinity, can you see? Or positive, negative. Positive, negative, doesn't matter. So n could be positive or could be negative. So that is a definition, okay? So this is the definition of a periodic function.
Yeah.
Okay.
Oh, okay, I get that.
So, however, if you don't treat, so be careful. So these notation as too casual. It's not good idea to use this to as modeling. When you do modeling, you have to use the full parameters in this case. Otherwise, you can hardly do anything.
Yeah. Okay.
Because that's done here. All right. So basically, what you can, if you don't write the into this form, and you will get confused. So that is how we. Yeah, I think every textbook will treat these topics when you do modeling. And do you want to do more exercise, or do you want to do something different?
Something different. I'll just see if we. I'm not sure what the next chapter is.
No, we just doesn't matter. We don't follow the textbook. It's very. We just can. If I so talking about the modeling, okay. Can you just continue our this topic? Can you find a proper formula?
Yep.
If this if you say can we so this is y, this is x, okay? Can we find the the form of function which can model this curve? I have to curve here. You see the one? Can you see that there's an amplitude decrease? Can you see that?
Oh, what?
Yeah. So eventually you will see nothing. So because amplitude just decrease. Can you work out any function or combination of function that can represent this phenomena?
If it's a decreasing amplitude.
Yeah, the amplitude is decreasing. So origin is A. Origin is A. Is negative A. So without this, can you see? Without decay, they just keep that constant. These two, that is a magnitude. However, with the decay, then you have taken into account of this curvature here. You see? Can you imagine any function which can describe the green light?
Like an exponential?
Yes, that's right. Decay or growth. Yeah. Can we call this E negative? Can we call R here? R for the decay constant. Can you write down here?
Yep. E equals negative R. Yeah. Oh, E negative RT.
Yeah. How about this function? How about this periodic function? How about the pure? How to so how to use how about this? In other words,
you could use sine.
Good. Yes, you can use sine. So what would be the model? What would be the model function looks like?
It will be, well, since it's decreasing, A is changing, right? A is changing. Does that mean A is to the power of?
Yes, A is changing. That's right. Good idea. Yes, A is changing. Decay exponentially.
Decay. Oh, A is decaying exponentially. So then A is to the power of.
Yeah, can we use this function? Or instead of call T, can we call the X, because X is variable here?
Yep. A to the power of.
Yeah, can we just call the E negative RX? Yeah.
R is the
rate of the decay.
Oh, rate.
R, rate of decay.
Oh, so X is 1. So then, okay. Yeah. Is it 8 to the?
No. You have to look for the base. You have to when you describe the decay function, you have to look for what the base is. What is the base is?
The base is E. So
you can use base E. Yes, you can base E, because E is natural. It's called natural decay constant.
A would it be A times E to the?
Yeah, you're right. Yeah. You're right. So I just can we use a bracket for you? So this part will ensure you that the amplitude is decay
One number. Yeah.
exponentially. Anything else do we need to in order to find to describe this origin curve? Anything else do we need?
Sine.
Yes.
Very
What
else?
Well, can we call this distance? Can we call this distance peak to peak? Can we call this peak to peak? Can we call this is A? How about that one? Peak to peak is A. Yeah.
Peak to peak.
Yeah.
That's so then A X.
Not right. So that's why you see, yeah, it's nearly right. It's not bad. You are not bad. So when you give in this distance, which means what does it mean when we give this? Can we just draw the sine function here? Can we just draw another sine?
Yeah.
And draw sine function side by side. So I just that's good. We can apply our old knowledge now to dealing with this problem.
A is the period.
Right? So this is another function because this is y equal to. Can we say sine? Can we call it omega t? I prefer use omega, right? Omega t. So omega t here. But here is x, right? Here is just x.
Yep.
In that case, can we just call this? Do you want to put a sine x? Did you say sine x here?
Oh yeah, there's an x, but I'm just trying to figure out the period. T equals over omega. So T is equal to A, right? A is.
Oh, hang on. Probably this is yeah. We have to. I will rewrite this notation here. Perhaps otherwise you can't just. Can we just rewrite this variable, independent variable, as t? Okay, not instead of x. Instead of x.
Oh, okay.
Okay, I just rewrite this part. That make sure. Otherwise, so can we call this x is t because the time constant, right? It's time dependent. So this time t. So basically, we have to use omega or use a b, right? Can we just use omega? Yeah. Omega time t.
Time t. Yeah.
That's it. But what is omega? In this case, what is omega? What is a? Omega. What is peak to peak? Can we just write down here? What is
a peak to peak is the period.
Yes, right? Yes, that's P. That's capital T, right?
Yeah.
That's capital T. Now, what is omega then?
Omega. So if omega equals 2 pi over A.
Yes. So what is omega? Yeah. Can you write it down? Can you just rewrite the formula a little bit?
Yeah.
Yes, you are doing modeling now. That's a series modeling. You see?
Oh, okay.
Yeah, that's right. That's correct. So basically, in this diagram, the peak to peak, any peak adjacent, peak to peak. Consecutive. Yeah, consecutive. So this is called T. This is capital. Okay, if that is so then that is a T. Okay. So you can do modeling now. So you can do modeling now. That is exactly when you hear the loud bang. Okay. So the sound behaves like that. If you just use this, if you just record a noise or someone. So for example, someone is knock something. So if you just see the time series, I just drew this diagram for you. So,
of the noise.
The noise, yeah. No, it's just someone, probably something, the crash or a collision, something. Crash or drop something, boom, something like that. So if you use microphone to record that, and then look at this time series, you will see that this is time. So in that you will see that it's just like collision. See, so they have the built up, first built up, and then die down. You see.
Yeah.
So you can try. You can record any any sound like this, Then if you
Okay.
expand that, you make sure the time is very interval is short, you will see that the curve.
Sorry. Yep.
That is how we. By the way, how do we describe? How do we just use graphical method? We just ask you how to describe this. How to describe this? How to describe this? How to use model to describe this this stuff?
Oh, it looks
This is called envelope. This is called envelope. Like letter envelope. Envelope.
Oh, is that what it's called?
Yeah, that's called envelope. Yeah, and called envelope.
Can you function? Is there a function for that?
Oh yes, we just call the function. Yeah, there's a many function can go like a parabola. You see, as good approximation is a parabola. You see.
Yeah, it looks close. It's close.
Yeah,
it looks
yeah.
close to it. Wait, so when you drop it initially, it's quiet, but when like the
so
then it gets loud.
The volume increase quickly, right, and then die down and decay.
Yeah.
Now, if I just for example, if I just call this is can we call this is this curve is ft. Can we call this?
Yep.
This is y. Okay, this is y. How to rewrite y? Well, how to write y here? Just give you a trial. So which basic function you can choose to get this to do this modeling?
The closest one would be
we know this given. So this looks like a parabola, but it's not parabola. Can we call this the curve? The green curve is envelope is called ft. Okay.
Yeah. Are we trying to model the envelope?
Yeah. No. The whole thing. No. There's the whole thing. We're trying to model this origin line, origin curve.
Oh, well, it looks like it's either going to be sine or cos, but
doesn't matter. Could be sine, could be cosine. Yeah, right.
Yeah. Probably sine, I think.
Yeah.
Because.
Yeah. Do you want to write? Do you want to help you write?
Yeah. So
just ft, ft, yeah. Right? Just ft. Just ft times sine omega t. That's it.
Yeah. Oh, so it's ft.
Yeah, ft.
Times.
Yeah.
So ft is the envelope.
Yes, envelope. Yeah. It's envelope. And then, yeah.
Oh, so y equals ft times sine omega.
Yeah. Why time? Why don't plus? Because you can. Yeah, that's another thing. Can we just go to the second page? I will draw that. Yeah, this is something we can expand that your ability to modeling, because when one of objective to study specialist math is do modeling, right? So you apart from sine wave, and you have to more you can model in principle more complicated curve like the one we just saw.
Yeah. All right.
So basically, this is called this is very important. But if you don't study physics, I just give you introduction. This is just some background. It's called do you know our radius? And in old days, the radio must be transmitted. Or even today, we still use this called carrier. This is called amplitude modulation. It's amplitude. Can you see? Amplitude modulation. It's called modulation. I tell you why. Modulation. What does modulation mean? So basically, they have two signals. They have signal, right? You have signal, so you got a signal.
Yeah.
Signal. Yeah. We got a signal, right? Then we got envelope. Also envelope here. Okay. We got envelope. Okay. So can we call the envelope is can we call is f? Can we call it ft?
Yeah.
And the signal can we call it st? All right. So what happened is that in those days, that is a standard methodology. Even today, I think in and mobile phone technology also uses this principle. The horizontal one is time. It's called time series. The time series. I will draw the resultant. The third one will be resultant. Okay, resultant. So basically, if you have this, can we say The first is irregular. The first thing is just irregular. Can we? But perhaps I just use sine. I just draw sine here. I draw the signal. Signal is sine wave. So, but it's not exactly sine wave because you got. Let's just talk about sine wave to simplify. I don't want to go too complex. So basically, the signal is is weak like this one. You see, that's a sine.
Yeah.
Okay, that is sine.
Yeah.
Sorry. Roughly the sine wave. And the modulation envelope could be different. An envelope you can also use sine. A particular example to choose is can we just use this envelope? Can we use this envelope? Can we just use envelope here?
Yep.
How can you how can you write this model? How can you write this
that's
model?
like a. It's
always
like
positive. Always positive. It's
you need to do
positive.
you need to have like an absolute value.
Yeah.
Like you can use the like this, so you get always a positive
or you can
value.
alternative you can use a square.
Oh, square, yeah.
Yeah, you can simply use a square. Okay. For example, if this case was fx or ft, sorry, ft. That all the time t is variable. T is variable. Can you go t equal to say sine omega 1. Can we just use number? We don't use omega, too abstract. If the omega is if period is large, omega must be very small. Can you see? So it might be 0.001 t. Okay, can we use this one? Which means the period is large. Okay. On the other hand, can we use A1? This A1, this A. Can we see this A2, right? It's this formula. So this formula will equal to A1 sine is also sine, but this is large ones. Can we call it 2t?
It's two, yeah, because that means the period is very small.
Yeah. So in other, this is high frequency, right?
Yeah.
The period is short. So if you multiply the third one, this amplitude. This amplitude is called AM. It's called AM. Okay.
Yeah.
Do you know FM and AM?
Have
you heard of FM?
Yeah.
Yes, right.
Yeah, I've heard of them. I don't know what they mean though.
FM, and that's I just talk about. FM is different. We're not talking about that. FM is frequency because you are not studying physics, so I'm not going to talk about. So it's called frequency.
Yeah.
But sometimes you have to pay attention to the application side.
Yeah.
Modulation. It's called FM. So if you listen to some, good music, you have to go to FM because that sound quality is much better.
Yeah.
But we just go talk about it. In our case, if you use MM, it's called the magnitude modulation. So basically, they say you just use S signal time multiply F signal. So what will be the resultant of this product?
If it's S times F.
Yeah, it's similar to the one we just discussed. Can you imagine what would be resultant? So basically, if you time this game, this is 0, okay? This is a good way to say if you multiply here, when that's equal to 0, and this will be back to 0, can you see? Back to 0. When you time large number, that will be magnified, can you see? You just correspond to that will be magnified, can you see?
Yeah.
And it go back to 0 again. Okay, 0.
Oh yeah.
And let's go up again, can you see?
Yep.
So resultant, the effect will be like this. So what will happen is, oh, by the way, because the owner changes the magnitude, not the sign, see? So in this case, a negative, positive and negative still remain. So what you will get here, can we just write roughly? So it will be like this one. So build up, can you see? And die down. And build up again, can you see? Have you seen this signal before? Can you see? So basically,
so it builds up.
So this called again this kind of envelope. Can you see? Okay, envelope here.
Yeah.
So if you do the modeling, then I will stop here. I will not go too far. But this is another thing to tell you how to do modeling by using basic function. In this case, we just use a sine function.
Yeah. Oh.
Okay.
Oh, damn. All right. Yeah, it makes sense.
Let's give something, extended knowledge to study the geometry. Do you want to pick up some problem solving from your textbook?
Yep, I'll just take a look.
What can I do? I will just stop this sharing. You can share with your textbook with me.
Yep.
I will make sure there's no constraint. Oh, yeah, by default there's constraint. Okay. Can you pick up some difficult question, challenging question?
Yeah, let me look at this one. Oh, here's one. Here's a pretty hard one. Let me just share my screen.
Yeah, that's right. Okay, yes. Oh, this is modeling. Hey, I saw the modeling immediately. Yeah, that is, can you see? That is modeling. That is modeling. Can you, okay, that's fine.
Sorry.
I have
you want to zoom in or?
Annotate. Okay, I can see. I don't, you don't have to show this part to me. You just unfold it. So that we got a larger screen.
Let me try and see. Can I?
Oh, this. Yeah. Okay. I can see. Okay, that's enough. That's all right.
Oh, I can close both of them. Let me just.
Doesn't matter. I can see it now.
Yep. Sorry.
Okay. Yeah. Can we just? Yeah. It's all right. Can we just do something? Can we just answer some question of the number 8? Because it's just what we just have learned. This modeling.
Yeah.
Population of particular species of N varies with time, so it's periodically. The first question. Can you answer the first question?
Yep.
Which in this there are all numbers. Which number are amplitude? Which number are magnitude? Sorry, period. Can you answer this question?
Yeah. You state the period.
Yes.
Well, so this is equal to.
What is the period?
Pi over 26.
Yeah.
Times t minus 10.
Yeah.
So then would the period be 2 pi over pi minus 26?
Yep, that's right. It's right. That's correct.
Which equals.
Oh, that's all. Or just divide by 12, right? 13, sorry, 13. Hang on, no. You got a silly mistake here.
Oh, yep, I see what I did.
Pi canceled, pi canceled, right? Pi canceled, there's no pi.
Yeah. Which is 52.
Yep.
Yeah.
So what is the amplitude?
Amplitude is 3000.
Yes, good. What is the range?
So the maximum value is
you have to draw a diagram to help you.
Yeah.
Okay, you can help to draw a diagram here. You really have to do is to draw a diagram. So you draw a diagram here. We know that the 4,000, can you say 4,000 is a shift. So if you draw this 4,000 here.
Yeah.
Can I write down something? Yeah. So this is 4,000, right? Oops, sorry.
Yeah.
Can you do that? So this is 4. Oh, you are doing what you're moving?
Oh, it didn't move.
So this is 4,000. See, this is 4,000. Can you see? Can you just fix that? It's 4,000.
Yep.
So they say the magnitude is 3,000. So basically they can go up. So you can go up here and from here to here. Can you see? That'd be
Yeah.
that's be 4,000 minus 3,000. That would be, so
Yeah.
this is, can you label this part? What is this thing?
Yeah.
What is this part? So that would be, so basically they were something like they removed, so that would be oscillation, can you see? That
Oh,
is
so
oscillation.
so
you have to, the range is for y, okay? The range for the n. So what is the range? Say, what is the A and B? What is the range for n?
so does that mean if the amplitude is, I mean, if the shift is 4,000, that means
Yes.
the equilibrium is at 4,000.
That's right. Equilibrium will be
At 4,000.
or 4,000.
Oh, because in the normal function, it's like plus,
zero.
it's at 0.
Yeah.
So you don't
normally,
even need.
normally you just the equilibrium position is 0. That's why the reason you saw, once you see this 4,000 or negative number, you have to shift that immediately. That will be, so this axis will be n. This horizontal will be t, right?
Yeah.
Now, can you find the range for the function?
Well,
yeah.
the maximum is 7,000.
So 4,000 plus 3,000. Yes, that's right.
Yep. And then the minimum is 1,000.
Yes.
So the range is 6,000.
Yep.
Right.
Well, you just range is or you just use this notation. So
just use a domain.
No, it's a domains for the x. Domains for the independent.
Oh yeah, range. Oh, that's what I asked. Yeah.
That would be, so that one can equal. Can use this? This is the equality sign.
Yeah.
7,000. So we sometimes will have slow down. Can we just keep doing this exercise because we just have learned this yesterday and today?
Yeah.
Can we just clean up everything?
Clear? Yeah.
Clear. Okay. Now can we just try? Can you continue? Can we try B? Do you know how to solve the B?
I think so. So state the values of n0 and n100. So n0 equals.
Let's substitute, right?
Yeah. Sine pi. So negative pi.
Yeah. Be careful. It's negative. Yeah. Yeah, that's right.
Which equals 1,000 sine.
Can you? That's enough. That's enough. Can we just improve your writing? We normally put a number in front of pi. Okay.
Put the number first.
It would be 10 pi. Okay. Write it 10 pi, please. Okay. Because this for the alien. This notation is alien. It's not easy to read.
Yeah.
Okay, that's it. So what anything else? Sketch is a graph. Oh, we have done. We have done that. Yes. Oh well, because I did it for you. Next time you do it, okay?
Yeah. Oh, I think I have to sketch it. Might need to sketch it again for C. It says find the values of. Oh, actually, no, I don't need to sketch it. I just need to solve it.
You can use algebra. You can. This is a typical question that you can either use the graphic method or the algebra. You can combine the both methods to solve the problem.
Yeah.
So what are you looking for? Find the value for t. Oh, okay.
So
they have the inverse function, right? You have the inverse function.
Yeah. Sine pi t minus 10 over 26. Would I divide? Oh.
No. What are you doing? So this is 4,000. How can you get 1 here? Oh, you have done that. Oh, that's right. You're right. Is it right? You're right. So basically, the sine value equals 0. Yeah. So basically, can we just rewrite that? So you got a sine theta equal to 1.
Like
so what would be the
theta equals 1?
Yeah, if that's so, what would be the theta? Just let's focus on theta first.
Pi over 2 or
no. 1 is pi over 2. Yeah, pi over 2. That's right. That's right. And in other possibility, pi over 2. No.
Well, you could have,
Plane
oh, you can
versus-
add 2 pi. You can
yeah,
add 2 pi.
Yeah, pi, yes.
N pi, sorry.
2n pi. Can we say 2n
2n
pi?
pi.
Yeah.
Yeah.
So
Any
n
variant
equal
of
to
that, yeah.
1, 2, 3. So this time, actually, you take longer time than I expected. You have to use trial and error to work out what is, because you get a range, okay? You have worked out the range.
Yeah. They give you the, yeah.
Can we solve this? Can we solve the problem on the properly on the whiteboard?
Whiteboard, yep.
Yeah.
Yep.
Can we just because this is not easy. It's not straightforward. So basically, can we just go back?
Oh, I think I have to stop sharing screen first.
Yeah, you have to stop sharing. Okay.
Oh, good. Yeah.
Okay. So we go back to the whiteboard. We do it. We do it properly. Okay. We're not in the wrong. We just have to make sure that is that's problem solved properly. This time we're not right. Just right starting from your results first. From starting the results.
Yeah.
So just tell me. So in this case, we have. I just copy your result. You got. So basically, sine theta equal to 1, right? So what is theta in this case? Theta is pi. 60,
pi. Oh yeah, t
pi
minus 10.
T minus 10, yes, divided by 62 or something.
26.
26. Okay.
Yeah.
All right. Now, can you solve this problem properly? Can we just solve the theta? Can you try it? Can you just solve the theta first?
Yeah.
How to denote the solution?
So theta. So this is 1. Oh, can you see my right?
No.
This is 1.
No. Yeah. What is the formula for theta? You have to write properly. What is the?
You have 2 equations, right? Like you know that.
Yeah.
Theta equals pi over 2 plus.
Therefore, yeah. 2 pi.
Right.
Yeah.
So this is 2. So you just what you can do is.
So basically, you have to determine the range. What is the range for t? Can you check the domain?
Yep.
I think domain t is
0 to 100.
100 only.
Yep.
Okay. So you have to solve it. So basically, how many theta? Can we just solve this? Can we solve this theta first? So theta 1 is equal to half pi, right?
Yeah.
How about theta 2? Another solution.
Half 5 pi over 2.
Yeah. No, the 2 pi. No, that'll be sum. Will be equal to 2 pi plus, right? Plus half pi, plus 3 pi. Sorry, plus 2 pi.
Yeah. Oh yeah, I just wrote 5.
Yeah.
5 pi over 2. Yeah.
Oh, you got it already. Okay.
Yeah. I think yes.
Oh, you're quick. Oh, that's quick. Okay. I think you're good at this mind calculation, right? That's good. That's good. Okay. The trouble is, so you can go on, but this is just the alternative that you can go back, right? You can go back to solve this n, to solve this maximum n. By equal, can we solve that? Can we substitute the largest t here? What is the largest t? Oh, hang on. Theta from negative, right? Aha.
Do we have to solve for
you see, when theta equal to 0, theta is negative, right?
When theta equals 0.
Yes. You can see here. So t equal to 0, the angle is negative. So in other words, we have also considered the negative. So basically, yes, that's not easy. So you have
plus
to consider.
Or minus.
Yeah, can we just draw a dependence diagram here? Can we just draw a dependence? What's called a dependence? So basically, they have 2 variables here. They are linear function. Do you agree? If you just do this, let me show me what I'm going to do. So this is theta, and this is t, right? So this is t and one is theta. Do you know what I'm going to do? So basically, we have to we have to slow down. This is theta, okay? This is a t, right? So when t equal to 0, what is theta? When t equal to 0. Yeah. Oh, can we just rewrite this linear equation? Can we just rewrite? Can we rewrite theta equal to pi over 26 times t?
10.
Yes, yes. That's divided by 10. So that is, can we use 513 pi? Can we see that?
Yep.
So therefore, when t equal to 0, theta equal to negative 5 pi
Over 13.
over 13. So you have to find this first. This negative number, right? We don't know what. This is just a sketch. Okay, you don't have to represent it. So this is 5 pi divided by 13, right?
Yeah.
Now, how about the theta? How about t equal to 1,000 or 100? 100, not one. I'm talking about the range,
Oh,
the
range.
domain. Can you work out the t equal to, what is the theta value when t equal to 100?
When t equals 100.
Yeah, this is not easy. It's easily take you half hour to solve this problem.
Yeah. Wouldn't a simpler way, just a simpler way be?
No. Whatever is simple, you have to work out how many possible theta.
Yeah. I think like in like a test or something, you'd have to draw the diagram first, and then you can see as well, and then you just need to like.
You do it. You don't talk. You do it. You do it. Okay. I just watching.
So if it's 100, it's 105, 50 over 13.
Oh, hang on. This is not right. Hang on. This is not right. This is negative here. 5 pi.
Oh, yeah.
5 pi over 13. Yeah, that's his.
Yeah.
This is called y-intercept. Can you see? You still use the base. It's called the y-intercept. So it is y-intercept.
Yeah. Oh, which equals 5 pi. Oh,
by the way, can we just use workout x-intercept straight away? Can we work instead of use this number? We know it doesn't matter. We still need this number. Can we? We still need this number. Yeah. How can you simplify that? You can't. This is not a number, right? 13.
Oh, I did that wrong.
You can do that. 45 divided by 13. Is that divisible?
No, that's
divisible?
wrong.
It's divisible.
No, I did that wrong. I thought it was I'm just
We have to stop there. We must just just wait until the graph looks like what the graph looks like. Yeah. So there are either way to draw this straight line. One is work out the t at 100. So this is t at 100, or you can solve the x-intercept, right? Either way. So basically, now I just use a graph here. So basically, it's a linear function dependence, right? It is will be a straight line here. Will be can I use it's not.
So for a question like this, the method is to, since there's multiple answers, the method is to, you need to find out first how many times, how many times you've got t in its range. So you need to figure out. That's what we're doing, right? We're trying to figure out how many times.
We know what they are all possible. All these values are possible. Okay. So this is general formula here. So all these values are possible, but we have to choose the right range, a right domain, because the t is confined to 0 to 100.
Yeah. So we're trying to find.
Yeah, this is a general formula. This is general formula. Yeah.
So we were trying to find we're trying to find t, and
we need to determine the t. We determine the t. So because obviously this is more than one t, right? There's more than one t that values appear because it's periodical. Think about it. It's periodical, right? It is periodical. Therefore, if you give, can we just draw this graph here? It's easy. Sometimes it's very important that we stick with one example to fully understand what how many options, how many basic concepts involved. Can you see? If you just draw the periodic function, say sine function, I just draw it quickly. So basically, so if this is sine function, so do they had they had intercept just here? So basically, got it's not necessary. Can we just draw that one? So may or may not like this, but this simplifies. So therefore, if you just in this case, if you just give in the, say this is the y value, the function value, like the one they just give you, then they got plenty of the choice. Do you agree? Plenty of choice. So if you can just rewrite this one. So this is our time, or x, this is time t. So this is function itself. Can we call it ft, right?
The white line.
That's right. If you just give him one value, then you got a plain lot of solution. Can you see? 1, 2.
Yeah.
So many solution. Now the idea, you can go to detail. We can go to detail. Basically, you have to be aware what does it mean, and also in this case, the t can be negative. The theta can be negative, right?
The angle can be.
Oh, hang on. This is not the t. This is theta. I have to slow down. So this is theta. Okay, we're talking about theta. The explicit function is theta. We're talking about sine theta, right? So theta, so theta is a function. Say theta is a function of t. So that is a linear function. Can you see? Theta is a function of t, but for theta, they have plenty of theta. So another thing you have to consider to solve this problem is that theta can be negative because the theta can be negative. T is always positive, but as we notice that at t equal to 0, theta is negative, right?
Okay.
So in that, this is not easy. So this question you have to consider a lot of the issues. So can we just draw one of them? Can you see? So in this case, you have to consider whether these were taken into account. Okay.
So in this graph in the top right, the independent variable is theta.
Yep, and but finally, the theta is a function of t. It's just a composite function. Do you know the composite function?
Yeah, sort of. Yeah,
X. Do you know this notation? Do you know this notation? Or they just use f, just theta and t. Either way, it's called a composite function.
F is a function of theta, which is a function of t.
It's called a composite function. Composite. Do you know the composite function?
Oh, we've done a little bit on it before.
So it's function. It's a function of the function. So it's called a composite function.
Yeah.
Okay. So the complexity of this problem is that you may have to involve to consider negative value for theta, right?
Yeah.
The range given. So this is not the range. The domain. Can we just use a different color? Can we use the domain? Can we call this? This is domain. So domain is here, can you see? Domain is here, something like that.
Those values.
Yeah. So basically this corresponding to. So this is theta when t equal to 100. This is theta when t equal to 0. Can you see the diagram here?
Oh, I see. Yeah.
Yeah. Do you want to try? Do you want to continue?
Oh, so the y-axis in this graph.
Yeah.
Is this? So it's what this is equal to sine theta, right?
This is sine theta. F is sine theta. Yeah. F is sine theta. Yeah.
Oh, sine theta. Versus theta. Oh, that makes sense.
That makes sense. Yeah. So theta is a function of t, and f is a function of theta. That's why. It's called a composite function. It's called a composite function.
Yeah. So sine theta changes for Okay. And the difficulty in this question is that you have sine theta equals 1, but then this could happen at
more than one time interval.
More than one time.
One time point. Then more than one, because it repeatedly happen.
Yeah.
So you should be able to find exactly how many time point which satisfy the value equal to the given value. 4,000, 3,000, I don't know.
Okay.
Do you want to try? Do you want to try? So this is,
Yep.
we just keep these two numbers here. That's all. Can we write down number here before we clean up this side? So basically, so this part, so this value, so this is, can we write one here? There's a 45. I copy your result. 45 pi divided by 13, right?
Yep.
And the first one is this number, so we'll clean up other things. So we can clean this one. We can clean everything here. Okay, do you want to try how to solve it?
Yep. So it will be at equal intervals because it's a straight line. So.
Oh, it doesn't matter because we have to work out these each time point.
So it's for 100, and then for 0, it's, what do you call it? Negative 5/13. So the difference between these is 50 pi over 13.
Mm-hmm. That is the largest value, possible value for theta. So therefore, any solution from this form, from any solution, I just give you some hints.
Yep.
So any solution angle, any solution from this formula must be smaller or at the most equal to this value. That is constraint.
Yeah.
That is constraint. Do you want to try?
Yep. So just. So now we figure out.
Can we solve the maximum n first? Because we know n is integer, right? N is integer. Or you can think independently. I don't want to speak too much, and you can do it independently. So I just remind you here that n. So basically, we just clean up. You just think I just clean up this side. Can you just keep trying, please?
Yep.
So just say that.
So
we don't need that. We don't need this one. We don't need that one. We know that is equation 1, equation 2. So in equation 2. So basically,
when t equals 100.
So that is n equal to 0, 1, 2, 3, and so on. This is called equation 2. That's it. So we got 2 equations here.
Yep. Oh, damn. I have to times by 19 minus 13.
Yes. Yeah. How can you solve the n? Can you factorize divided by pi on both sides?
Okay. Yep. So that means 70.
Oh, I got integer now, nearly integer, right? Oh,
yeah.
Nearly. Oh, but it's no, it could be integer. Eh? No, there's 77 now. It's not integer. So roughly, so you have choose the proper number, the maximum number.
Yeah. So n equals 77 over.
50.
It should be an integer, right?
Yeah, just a few. Yeah, just well, you can't be. There's no guarantee. Don't expect got integer. It must be just decimal fraction.
But
or what called a rational number.
Yeah.
Fraction is just fraction.
But for n, right? So the only time when sine.
What do you talk? You just can. What is n? We're looking for this number. What is approximate n? Yeah.
What, I'm not sure how it cannot be an integer because it's pi over 2.
There's no guarantee. You see, as I say, the t has nothing to do with theta. You see, the solution requires n is integer, but this doesn't mean that t must have the maximum. There's no guarantee that the maximum theta will be exactly is part of the solution.
Oh, okay. All right.
Confused?
A little bit.
No, it's not confused. Can you see? I just waiting for you. You should be able to solve that. Can we use the graphical method to show you? Can we call this theta 1? Can we call theta 1?
Yep.
Theta 2, theta 3, and theta 4 is beyond this scope. So therefore, if that is the case, you only choose n smaller equal to, at most, equal to 3. That is a hypothetical, right? Now what is n here? Yeah, you almost get here. We should be able to. So n equal to 77 divided by what is nearest smaller integer? Makes sense? What is, can we use decimal? Can we just solve that?
One and a bit.
77 is the calculator. 77 divided by 52. Let's do it seriously.
That's almost 1.4.
1.48. Okay.
So
therefore, yeah.
Close, but
yes, right. Because n is just n is must be integer. So the maximum. So the n maximum must be equal to the n must be smaller or equal to 1. Or just equal to 1.
Yeah, okay. Oh, so there's only a couple values. Yeah.
Just one, yeah, one value, I think. Two values. I hope this, see, sometimes we really have to go to some concrete example. I think this is a good example.
Yeah.
You're lucky you found this question right away.
Yeah. Oh, this
well,
is
you see,
quite
you have to sit down. You after this lesson, you have to sit down to spend probably 10 or 15 minutes. Can you save this page? Can you save this part?
Oh yeah, I already saved it.
You save that, and to figure out your strategy. How this is another issue. Did you want to save this page as well?
Yeah, I'll save it now. Yep.
This one.
Yep, got that.
Okay. So I think you have to, this is typical and very useful and very, how to say, versatile, this example that involve a lot of considerations. You have to think carefully.
Yeah. Oh, yeah.
All right, I'll see you next week.
All right. Oh, yeah. All right, then. I'll see you next Monday. All right, then. Good night.
Goodbye.
Bye.